Problem 31 is a typical example of an object launched upward at an angle. A lion can jump to a maximum height of 3 meters and cover a horizontal distance of 10 meters. We need to find the magnitude and angle of the lion's initial velocity. If you can visualize the projectile motion shown in the diagram, you're already halfway there. Also, remember that the vertical velocity at the peak is 0 and the total hang time is twice the time to reach the peak. First, set the coordinate system and origin. We'll use a Cartesian system with the origin at the lion's starting point, the yellow dot. In this case, we need to find the initial velocity given that the maximum height is 3 meters. Vertical motion is free fall. Since we don't have information about time yet, we can use the formula relating velocity and displacement to find the initial y velocity. Thinking only of the vertical motion, the final velocity at the peak is 0, and we plug in negative 9.8 for gravity. Calculating this gives an initial vertical velocity of 7.67 meters per second. The positive value confirms the lion is jumping upward. Always keep the signs and directions in mind. Now we can find the time it takes to reach the peak using 3 different formulas. Any of them will give the same result. The simplest way is using the relationship between average velocity and displacement. The initial velocity is 7.67 and the final velocity at the peak is 0. Plugging these in shows it takes 0.78 seconds to reach 3 meters. The second way is using the final velocity formula with gravitational acceleration and initial velocity, which also gives 0.78 seconds. The third way is using the displacement formula for accelerated motion, which yields the same result. I recommend practicing with different formulas to get comfortable. Now let's calculate the horizontal motion. The horizontal velocity remains constant throughout. Since it took 0.78 seconds to reach the peak, it takes another 0.78 seconds to fall back down, making the total time 1.56 seconds. In constant velocity motion, distance equals velocity times time. Substituting 10 meters for distance and 1.56 seconds for time, we find the horizontal initial velocity is 6.37 meters per second. Now we have both the horizontal and vertical components of the initial velocity. Let's find the total magnitude and the launch angle. The magnitude of the initial velocity is the square root of the sum of the squares of the components, which comes out to 9.97 meters per second. The jump angle is the inverse tangent of the y component over the x component, which calculates to 50.3 degrees. One more thing to note about projectile motion. If the launch and landing points are at the same height, the initial and final velocities share a specific relationship. The x components are the same, the y components have the same magnitude but opposite directions, and the angles are equal. Visually, the initial and final velocity vectors have the same size but are reflected. This is a classic angled launch problem. Make sure to review this carefully to fully understand it.